When it comes to speed, Vorticella is king. A cheetah at top speed is fast, and it'll cover about 15 of its own body lengths in a second. A diving Peregrine Falcon trounces the cheetah with a speed of approximately 125 body lengths per second. Vorticella beats them both. Its speed of contraction is 10 times faster once again at more than 1,200 body lengths per second. Vorticella is a bell-shaped organism and commonly possesses a slender stalk that is strongly fixed to a solid matrix. The speed of Vorticella that we're talking about is, of course, the extraordinary reeling in of the cell body by the stalk. What is in the stalk that facilitates this contraction is a structure known as the spasmoneme. The spasmoneme, also known as the myoneme, extends the length of the stalk and wraps within it helically. Think of the stalk as a barber pole with a spasmoneme for stripes. The critical components of the spasmoneme are the spasmin proteins, which bind calcium. A release of calcium from the endoplasmic reticulum in the cell body triggers a further release of calcium from tubules in the spasmoneme. The calcium binds the spasmin, initiating a lightning-fast wave of contraction towards the base of the stalk. So the contraction of the stalk is lightning fast, and I'm sure you've seen that the extension, or recovery, is much, much slower. Which one do you think would require ATP? If you said contraction, I'm afraid you're wrong. The calcium is released and binds spontaneously to the spasmin upon stimulus, but the pumping back of the calcium into the storage compartments, which allows the spasmoneme to relax and extend, is endergonic. It requires ATP. I hope you enjoyed this episode, and I'll see you later. Thank you very much for watching.